Welcome back. As siqhubeleka with our problem, now silapha question 3, use the expansion to estimate. Oh no, asikabikho lapho, silapha. For which values of x is the expansion valid? For which values of x is this expansion valid? This expansion is valid, but this is not true for all values of x. This is not true for all values of x. I'm not going to do lots of examples because this is true, guys. If you don't believe me, then you can try all the numbers. Okay. I guess I will need my calculator here. Okay, so now this question is so easy, and it's usually 1 or 2 marks. Why? Now, before I do this question, let's consider this. Consider the expansion 1 plus ax to the power n equal to whatever, right? Equal to whatever. I've shown that this I've expanded this before on the previous video. If you want to get to that video, khangela nje apha phezulu kwi-screen ikhona leya video. Okay, so now sizifumana njani Chawana we-Living Day Dream Academy i-values zika-x apha that are valid for the expansion? Then now take this that I'm giving you right now as the formula. So in the formula, the absolute value of ax, absolute value of this part has to be equal to 0. So when the absolute value of ax is less than, I'm sorry that I said has to be equal to 0. When the absolute value of ax is less than 1, then always the case, those values will always be valid. So for this expansion, we know that with the absolute value properties, so this is the same as -1 less than ax less than +1. Then we can divide by a on both sides so that we get -1 over a less than x less than +1 over a. So these are the values of this expansion, or are the values of x where this expansion is valid. Okay, let's go back to our original problem. This is the formula. Make sure you write this down. I'm sorry, guys. Then the math level up. Make sure that you have your calculator with you. Okay, now here our a is 1, right? So the values of x where this expansion is valid are, it's where the absolute value of x is less than 1, and that's it. Meaning it's where -1 is less than x, but x is less than +1. Then you get awarded full marks for all x in real numbers. For all x in real numbers. So this expansion is valid. So this is how you answer. This expansion is valid where the absolute value of x is less than 1. Then you from here, okay, this expansion is valid for the values of x where the absolute value of x is less than 1, which implies that -1 has to be less than x, but x should be less than 1 for all x in real numbers, right? For all x in real numbers. So it's always the case now. How do we show that? How do we show that this is true? I'll make umzekelo omncinci for you guys. It's always the case, good people. It's always the case. Now let's consider. I don't know what happened. I don't know what happened to my marker. Let me use this one, the other one. Consider x equal to, remember x should be in between -1 and 1. So let's consider x equal to 0, 5 and x equals to +2. This was -16. So 1 plus x, I'll just use the substitution. In the place of x, now I'm substituting 0, 5, which is the same as 1/2, but 0, 5 to the power -1/2 has to be equal, or let's say has to be approximately 1 minus 1/2, 0, 5 plus 3/8, 0, 5 squared, then minus 5/16, 0, 5 cubed, plus ... as it goes up until forever. Now let's use the calculator. Let's use our calculator. Let's start by this one. 1, okay, into 1 plus 0.5 to the power of -1/2. Then the answer to this is equal to 0.8164 ... equal to, this has to be equal to this guy on this side. So let's say 1 minus 1/2 into 0.5. When I say 1 minus this, then I get 0.5, 0.75 plus 3/8 into 0.5 squared. I get 0.9375 minus 5/16 into, oh my god, 5/16 into 0.5 cubed. Then I get minus 0.0390625 plus ... So now, if siyajonga these numbers are getting smaller and smaller and smaller. Okay, so now let's add only these 4 terms right here. So 0.75 plus 0.9375 minus 0.0390625. Let's see, what is it that we get? Okay, seemingly I made some mistakes. Where did this disappear now? Okay, let's punch it again. It's 1 minus. Hopefully you are also punching these 2 on your calculator. Hopefully you are also working here with me. I'm using inhloko yam, so these calculators now sometimes become problematic. Okay. Yes, and this is the answer. I guess I made some mistakes somewhere here, because when I punch this on my calculator, this is what I get. This is what I get. I get 0.804687 dot dot dot. Then on the other side I have 0.8164. So even if now remember that this adds, here we keep adding, here we keep adding. So when we reach infinity, it's clear that we will somehow end up to lento. It's clear that when we reach infinity, maybe we'll get to this, because 0.08 is approximately this, because if I were to round off this to one decimal, I'll round off both sides to one decimal, so I'll have this rounded off is going to be 0.8. Then I round this to one decimal, is going to be 0.8. Left hand side equals to right hand side. Good people. So remember that if we find the values of x for which the expansion is valid, use this formula: ax less than 1. Absolute value of ax less than 1, or should be less than 1, when you have something like 4 1 plus ax to the power n. Okay, good people, thank you very much. But before I said we should use 0.5 and also use positive 2. We should also use positive 2. So it's true. For x equal to 0.5 and 0.5 is greater than -1 but less than 1. So far it's true for for this. So it's true for this so far. Now let's test using these two and see if that is correct or not. Maybe I'm making this video long, but I want you guys to understand almost everything. So now I will simply substitute 2 there. I'll have 1 plus 2 to the power -1 over 2 equals to 1 minus 1 over 2, 2 plus 3 over 8, 2 squared minus 5 over 16, 2 cubed plus dot 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 dot. Then now let's find out what is it that we get. I'll start on the left hand side. 1 plus 2 raised to -1 over 2. Then I get 0.5773 dot dot dot. Okay, then now let's come this side. 1 minus 1 over 2 into 2 plus 3 over 8 into 2 squared minus 5 over minus 5 over 16 into 2 cubed. Then I get -1. Is there a way that 0.57 or 0.6 can ever be equal to -1? Then no, it's a big no. So it's false for x equals to 2. Therefore, good people, stick to the formula that I've shown you, that the absolute value of ax should always be less than 1, which means that -1 should be less than ax, but ax should be less than 1 for the values of x ezenza i-binomial expansion ibe correct. And thank you very much. Now I will go to the last problem.